Hello everyone, and welcome back to the Fluctus Channel. This is the Cheyenne Mountain Complex, located beneath 2,000 feet of solid rock inside Cheyenne Mountain in the southwest corner of Colorado Springs. Cheyenne Mountain was excavated by the Army Corps of Engineers to build the NORAD Combat Operations Center and became fully operational on April 20, 1966. Over time, the Cheyenne Mountain Complex accommodated elements of the U.S. Strategic Command, U.S. Air Force Space Command, and U.S. Northern Command, U.S. NORTHCOM. In October 1962, a major standoff known as the Cuban Missile Crisis brought the United States and the Soviet Union dangerously close to war over the deployment of Soviet nuclear-armed missiles in Cuba. After pledging in May 1, 1960 to defend Cuba with Soviet weaponry, the Soviet Union installed medium and intermediate-range ballistic missiles in Cuba, assuming the United States would not intervene. However, these missiles, if launched from Cuba, could strike much of the eastern United States within minutes, making the situation unacceptable. On October 14, 1962, U-2 aircraft flying over the island confirmed the existence of a ballistic missile at a launch site. The United States chose not to pursue an immediate invasion. President John F. Kennedy opted to impose a naval quarantine or blockade on Cuba and declared that U.S. forces would intercept any offensive weapons and related materials that Soviet ships attempted to deliver to Cuba.
Within the past week, unmistakable evidence has established the fact that a series of offensive missile sites is now in preparation on that imprisoned island. The purpose of these bases can be none other than to provide a nuclear strike capability against the Western Hemisphere.
As both superpowers stood on the edge of nuclear conflict, diplomatic messages were exchanged. Ultimately, on October 28, 1962, Russia announced that construction on the missile sites would cease and that the missiles already in Cuba would be returned to the Soviet Union. In exchange, Kennedy pledged that the United States would never invade Cuba and secretly agreed to withdraw nuclear-armed missiles from Turkey that had been deployed in earlier years. Soon afterward, both sides began honoring their commitments, and a major war was averted. The construction of the Cheyenne Mountain Complex was finished shortly before the Cuban Missile Crisis, and the importance of such a facility became strikingly clear. This fortified command and control center was viewed as a major breakthrough for defense against long-range Soviet bombers. Because of ongoing operational and security needs, the Cheyenne Mountain Complex is not open to the general public for tours. However, it is still possible to glimpse what lies inside this massive facility. A well-known tunnel leads to the primary entrance, which features two blast doors weighing 25 tons each. These doors were engineered to shield the interior of the facility from nearly any type of attack, including nuclear, biological, electromagnetic pulse, and several others. Anyone entering the Cheyenne Mountain Complex must pass through a security checkpoint. Anyone lacking authorization to access the complex is immediately escorted out of the facility. Moreover, The military personnel inside the complex monitor the surrounding area on large displays and report any irregularities to their superiors. The entryway into the Cheyenne Mountain Complex displays the insignia of 4 tenants, including NORAD, U.S. Northern Command, Air Force Space Command, and U.S. Strategic Command. There are multiple buildings inside the Cheyenne Mountain Complex, each rising 3 stories high. The main building offers various amenities for personnel, such as a medical facility, a store, and a cafeteria. Additionally, there are fitness centers located both inside and outside the mountain. The Cheyenne Mountain Complex was designed to withstand a nuclear blast or an earthquake. As a result, more than 1,000 massive springs are installed beneath 15 buildings within the complex, enabling the structures to shift up to 1 full inch in any direction. These springs are intended to safeguard both the buildings and the personnel inside. Alongside the giant springs, flexible connectors are installed between various pipes with the sole purpose of helping the complex's infrastructure endure a major explosion. The Cheyenne Mountain Complex is now overseen by Air Force Space Command and supports the activities of several tenant units. As of 2023, it serves as an alternate command center for NORAD and U.S. Northcom and is utilized for crew training. All the original functions of the complex were relocated to Peterson Air Force Base, situated in Colorado Springs. Currently, NORAD and U.S. Northcom occupy less than 30% of the floor space within the Cheyenne Mountain Complex and account for only 5% of the daily population at the facility. Previously, this facility functioned as a joint operations center for NORAD and U.S. Northcom. Several other units, along with U.S. Northcom, supported the NORAD missions. The Cheyenne Complex was a defense hub of the United States and backed aerospace warning and control missions. It was also capable of issuing alerts against ballistic missile or air attacks targeting North America. The Cheyenne Mountain Complex was not the only high-profile underground facility operated by the United States. Since the early 1960s, the U.S. military has relied on underground missile silos or missile launch facilities for storing and launching missiles. A missile silo is essentially an underground vertical structure sealed by a 110-ton blast door on the surface. From the outside, this door resembles a large concrete slab, and little can be seen beyond the blast door. However, there is a vast amount of equipment and infrastructure behind that door that is unimaginable to an ordinary person. Typically, every missile silo contains a built-in launch control center. However, in the case of ICBMs like the Minuteman III, the launch crew is not stationed at each silo individually. Instead, 2 launch officers operate from an underground launch control center that is linked through hardened cables to 10 other silos. These silos together are referred to as a flight. The silos are spaced 10 to 20 miles apart in an effort to protect the flight from a hostile strike. Furthermore, all the launch control centers of a flight are part of a missile alert facility, where launch crews remain on duty 24/7 and maintain dependable communication with the President and Secretary of Defense. Complex construction does not only occur on land, but also far beneath the ocean's surface. Divers have played a vital role in the U.S. military since the start of the 20th century. Numerous units and teams dedicated to underwater operations have been established within the armed forces to expand their capabilities across any environment. This includes the specialized units from the U.S. Navy Seabees known as the Underwater Construction Teams. The complexity of the missions carried out by UCT members demands high levels of preparation to ensure that objectives are completed safely and efficiently. For this reason, training exercises are continuously conducted in diverse conditions to equip divers with the necessary skills for underwater tasks. The training program has evolved since its inception, reflecting the growing complexity of underwater construction missions and the demand for highly trained and specialized personnel. Today, training is divided into multiple stages, designed to build upon the previous one and ensure that divers absorb all essential knowledge. Over approximately 23 weeks, divers complete the basic engineer diver course, covering topics such as dive physics, surface-supplied air diving, and underwater construction techniques. Through this training, students develop proficiency in construction tasks like underwater welding, cutting, and surveying maritime environments. After finishing the course and gaining a few years of experience, divers can pursue the advanced course focused on diving supervisor training and demolition operations oversight. With this training, divers gain the ability to perform a wide range of activities, including maritime infrastructure evaluations. These assessments involve closely examining the physical condition and capacity of marine facilities. Using their training, UCT divers employ a broad array of tools and techniques to gather data on the condition of structures, such as docks and mooring systems. The latter is crucial for securing vessels in port, so its integrity is essential for the safety of ships and docks. When inspecting such systems, divers utilize several methods. The simplest approach involves visual inspections conducted by the team, searching for any signs of wear or corrosion in the structure. However, this type of assessment is insufficient on its own, so more advanced instruments, such as ultrasonic sensors, are used to measure thickness or bathymetric tools to map the seabed around the mooring system. Similar or even greater levels of complexity arise during underwater drilling and welding operations. In these cases, the tools used pose greater risks to divers and can have significant impacts on the surrounding environment. Therefore, to perform these operations, the team must develop a detailed planning schedule to ensure that the work creates minimal disruption to the marine ecosystem. When using tools that generate intense vibrations, such as pneumatic or hydraulic drills, attachment points must be carefully managed so the diver can maintain control of the equipment. In the case of welding, divers rely on hyperbaric welding, which can be conducted either wet in open water or dry inside a specialized enclosure. All of this expertise is essential not only for construction work, but also for underwater demolition. Such operations are carried out when it becomes necessary to remove outdated structures or eliminate hazards in preparation for new construction. These procedures generally begin with evaluating the structures to be removed, as well as the surrounding conditions and their vulnerabilities. This analysis enables the team to develop a demolition plan and determine the most effective methods to achieve the desired outcome. Before placing explosives, divers typically clear the area around debris or other obstructions using hydraulic tools or other equipment. Divers then wrap explosive cutting tape around structures, such as piles or beams, to cut through the material efficiently and allow the team to remove the components with ease. From hardened command centers buried deep within mountains to missile silos scattered across vast landscapes and highly trained divers operating beneath the ocean's surface. This script illustrates how the United States built layered and resilient defense infrastructure. Whether underground or underwater, these systems and the people who operate them ensure continuity, security, and readiness in the most extreme environments imaginable. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.